Usually, intrusion detection systems, they are helpful to monitor the networks and their activities to find out the intrusions and mitigate the intrusions, especially in the Internet of Networks, in cyber threats. So even though we have a lot of intrusion detection systems, still there are a lot of obstacles, especially when the database is imbalanced and when we are handling large volume of data in the Internet of Things. And that's the reason we are going to take this challenge and present the paper, how to handle those intrusions effectively, balancing the data sets as well as handling the large volume of data, especially in the Internet of Things networks. Usually, when we talk about intrusion detections, we have already set off predefined intrusion detections algorithms, where the components of intrusion detection algorithms are simply, I can say, IDA, that consists of data collection, data pre-processing, then we go for feature engineering, and we will design a model, we will train the model, and finally we will evaluate the performance of the model. That is what the general algorithm of intrusion detections for any machine learning or deep learning algorithms. So this paper proposes that kind of model design using intrusion detection algorithms, and here we are proposing the structure for modeling the intrusion detections using SMOTE, that is synthetic minority oversampling technique, we will discuss further, and PCA, principal component analysis, finally random forest. It is a kind of ensembling, that is, we are aiming to handle the data imbalance through SMOTE, we are aiming to handle feature selections through PCA, and then we are aiming to classify the intrusions through random forest. So meaning is, our data imbalance problem, large volume of data handling, and classifying of multi-class classifications, all those things can be handled efficiently through this ensembling approach. And moreover, when we want to train the model as well as evaluate the performance of the model, we need to take the data sets. In this paper, we tried with the public data sets because we didn't start yet with the real-time data collection. So I took 4 public data sets available in online. Directly we can check from www.CICIDS2017 or UNSW, NP15, BOT IoT, TON IoT. These are all some public data sets available for us to check the public available data sets. And here, using this approach, our ensembling method will handle multi-class classifications. I can give you introduction, what is the difference between binary class classification and multi-class classification. In case of binary class classification, we will just check whether attack happened or not, attack or a normal one. But in the case of multi-class classification, we can still go in depth into what type of attacks. So multi-class, we aim to make a normal or attack. In the case of attack, what kind of attacks have been detected? That is what multi-class classification through our approach. And finally, those model, our model using SMOTE, PCA and random forest classifier will be evaluated through its performance metrics like accuracy, precision, F1 score and recall. And this is the structure of our proposed model. And as I mentioned before, the intrusion detection algorithm consists of the predefined components. The first one is the data collection. For that data collection, I use public data sets. I took 4 of them: CICIDS 2017, UNSW NP15, BOT IoT, and TON IoT. Then that is data collection. Because of the public data set, I just kept it like a data set. Then the next step of IDA is data pre-processing, where we have 4 steps. As I mentioned here, categorization, missing value removal, outlier removal, and standardization. After the pre-processing, we go further. Instead of going here to the diagram, let me explain the steps directly. In data processing, first we are aiming to clean the data as well as reduce the dimension of the data sets. So in cleaning in the sense, first we will make the spaces, unwanted spaces. If the column has some spaces, we will trim the spaces, and we will remove null values. We will remove the column with a single value, that we will remove it. And also sometimes if we have some high correlated variables, then we will remove that columns as well. So those are all called categorization, missing value removal, and outlier removal. Especially, we aim to reduce the memory usage. So we converted our data set from 64-bit data into lower bits, like 16 bits or 32 bits like that, so that we can reduce memory usage. And finally, standardization. This is the place we are going to normalize the data set. The normalizing means we will make the features into having a mean and standard deviation for each feature we selected. And we will use the standardized formula for normalization, that is Z equal to X minus mu by sigma. After this normalization, each of the feature will have a mean of 0 and standard deviation of 1. And interestingly, in this particular pre-processing, all the string data, whatever the data types, will be converted into numerical values. So that will be easier for further classifications. And next one, class balancing. This is the first step of our new proposal called SMOT. Here, this is SMOT in the sense of synthetic minority oversampling technique. That means when the data are redundant, when the data set contains repeated values, instead of making a repeated or duplicate data sets, we will make a sampling of this data set, which will improve classifications further. So the SMOT will help to balance the data without duplicating the data set. After that, we will go for feature engineering. Usually feature engineering consists of feature selection as well as feature extraction. Selection in the sense from the data, we can understand the data qualities or visualize the data. And then from extraction, the basic features or important features can be selected, which is helpful for classification or which will help to improve the classification quicker. So for feature extraction, we will apply PCA, that is principal component analysis. In this example, I want to mention here, using scikit-learn tools of Python libraries, we used PCA, and among the 4 data sets, we selected only the 10 best features and ignoring less useful features. So meaning is, our classification will be very quicker, easier, and the results will be so accurate. And I will show you further. After the feature selection, we are going to split the data set. Here the data is normalized, the data is balanced, best features are selected. So when we are splitting the data, we will take 70% of that data for training and 30% for testing. And for this place, we are applying the random forest, which is supervised learning embedded method, and it helps to select best features from the random subset of features. Usually, random forest method is also known as extended bagging method. Bagging in the sense, it will choose the best features from the sample set of features. So after those classification, we will finally getting the multi-class classifications. I listed here each data sets and the intrusions. Yeah, intrusions we received or we found in each data sets, and each of this is evaluated through the performance metrics like accuracy on this data set, similarly recall, F1 score or precision, whatever it is, for each method we evaluated. And I will show you, this is the experimental setup. For practical reason I mentioned here, it depends upon the area you use. But for the presentation, I mean just for the presentation, it is not the real-time experimental setup. For the paper presentation, I took a small quantity of data. So I used just my PC system with 16 GB of RAM, Windows 11 and the Core i7 CPU. And I used Python code and executed the code using Google Colab. Actually, Google Colab is the online tool, and it is the Jupyter notebook implementation, and it allows most of the popularly used Python libraries like NumPy, Matplotlib. So those tools are very helpful for data generation and data visualization. And this is the sample I want to show you. After the SMOT and PCA, I am able to get, you can see all the 4 data sets, which contains especially 45 or 79 or 19 or 126 features, out of which we selected only 10 best features to describe the entire data set, so that I can take best features which will improve the classification further. And for each data set, this is the PCA analysis graph notations. And after this, we are going to make a confusion matrix. Actually, confusion matrix helps to give the visual representations of how many correct or incorrect intrusions takes place. Using those correct and incorrect intrusions notations, we can calculate the accuracy, precision, or recall, or effort score through the formula here. Interestingly, I can say here, when I was making a note, I just remembered the COVID one. If we say COVID positive means, COVID result positive means no COVID. If it is negative means it's existing. It's the same way. So if we say true positive, that means attack. There is existing attacks. If it is false positive means it's not attack but classified as attack. I mean falsely mentioned as attack. Similarly, true negative means no attack at all. It is normal traffic. But if we say false negative, it is an attacked one, but misclassified as a normal traffic. So like that, just for example, I compared with COVID. So using this true positives, true negatives, false positive, false negatives ratio, we can find out accuracy, effort score, precision, and recall. Then after that, I listed here. This is the multi-class classification report for the dataset what I have used for these 4 datasets. Please remember, this is the public datasets, and I'm not using entire dataset. For the experimental purpose, I took around 60 to 70% of data from online. So for that, because I want to make sure whether my particular design, small, PCA, and random forest is working or not. So that's why I took 60 or 70% of datasets, all of them in CSV format. So after this, you can see the individual multi-class classification of intrusions and their particular precision, recall, or effort score with accuracy for all the 4 types of data sets. And this is the overall summary of the performance metrics of my proposed model with the different data sets. And here I want to compare my proposed model with the existing approaches. So from the beginning, they are using, instead of SMOT or PCA, they use ANOVA statistical method to choose the features, and then LSTM, large short-term memory method. When they combine, using those 2 data sets, they are getting this much accuracy and so on. Just random forest or gray wolf optimization and particle swarm optimization with random forest. So these are all some kind of combinations, different combinations of prediction, feature selection, feature extraction, and classifications. So I compared with the existing approaches with the one what we proposed, and comparatively, compared with others, our proposed model is performing better than others. So with the result what we got before, we concluded that our proposed model is performing very well to extract the multi-class classifications with improved accuracy, precision, and F1 recall and accuracy. And using different data sets, we have tried our model and it works fine. And as a future research, we aim to combine privacy preservation of data set with the new concept like federated learning and blockchain technology into the intrusion detections. Actually, the proposed model is focused on efficient feature selection, feature extraction, and classifications only. But in future, we aimed to explore our knowledge to various concepts, the cutting-edge concepts like federated learning and blockchain technology to intrusion detections, which will be enhancing IoT security. Thank you so much.